Hello, welcome back to the channel. So let's continue our previous video and do one more question on calculating reasonable values which satisfy the inequalities given in the questions. And this will be a very important concept that we will use in order to numerically approximate integrals, complex integrals in some type of questions. So in this question we have been given f of x and we have to calculate a reasonable value of m such that this inequality will hold true. So let's first calculate the double derivative of f of x in this case. If we calculate the double derivative of f of x, we'll first calculate the first derivative, which would simply be, we'll use product rule for that. So it would be x cos x plus sin x, and then this would be minus 2 sin x in this case, right? So f dash x would basically be x cos x minus sin x in this case, right? And if we calculate the double derivative, we will take the derivative of this expression and it would simply be, we will again use product rule for the first term. So it would be cos x minus x sin x minus cos x in this case, right? And this will cancel out. So double derivative would simply be minus x sin x in this case, right? So now we have the double derivative of this expression over here. We have to calculate the maximum value of the absolute value of this function over here, right? So let's first calculate the absolute value of the double derivative of x, right? And it would simply be taking the absolute value of x sin x in this case, right? Which would simply be absolute value of x sin x in this case, right? We will get rid of the negative sign because we know about the property of absolute functions, right? So this is the expression for which we have to calculate a maximum value for. And now we are also given the interval in this case. The interval is from minus 3 to 2. So we know that x varies from minus 3 to 2. And we also know about the property of sine functions, right? We know that the maximum value of sine is 1. The minimum value of sine is minus 1 in this case, right? So if we have to make a reasonable guess about the maximum value of this expression over here, which would be the expression of the absolute value of x sin x, if we have to give a reasonable guess of what the maximum value of this function would be, since we know that sin x is a bounded function and its maximum value is 1, so we know that this expression will be lesser than or equal to mod x, right? Because the maximum value of sin x is 1 in this case. And now we also know the bounds of x in this case. X is varying from minus 3 to 2. And we know that when x is minus 3, this would simply be equal to 3 in this case, right? If we take x to be minus 3, the absolute value of x would be 3 in this case, right? So 3 can be a reasonable guess for the maximum value of this expression over here. And again, in order to solve this question, we only use the properties of trigonometric functions, since we know that sin x is a bounded function which can have a maximum value of 1 in this case. So we know that this expression will always be less than equal to the absolute value of x, right? Because sin x can have a maximum value of 1. So we know this expression over here, and then we also know the bounds of x, which are from minus 3 to 2, and based on this expression will hold the maximum value when x is equal to minus 3, right? And the maximum value would simply be 3 in this case, right? So for this question, since we were calculating a reasonable value, again a reasonable value for this inequality to hold true, our m is equal to 3 in this case based on what we discussed in this video. But there is also one important note which is also provided in the solution of this question, that the absolute value of the double derivative of f of x is actually smaller than 3, because we know that the maximum value of x and sin x cannot be simultaneously together, right? So for sin x to be equal to 1, x should be equal to pi by 2 in this case, right? But if our x is equal to pi by 2, this expression is lesser than 3 in that case, right? So we know that both of these functions cannot have their maximum values together, but since in this question we only had to give a reasonable value and not the exact value, we can assume our m to be 3 in this case. You can also read this solution over here. This solution talks about the exact value, the exact maximum value of this expression over here, which is 1.8, but since in this question we had to give a reasonable value, m equals 3 is a reasonable value because 3 is also very close to 1.8 in this case, right? So that is why in these type of questions, you don't have to always calculate the actual value. If you can get a reasonable value for which your inequality will hold true, that would also be your correct answer to this questions or these type of questions in these cases. So that's it for this video. Feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.